Okay guys, so here's the second part to this video on the path of the sun. And we left off taking a look at how the path of the sun changes with the seasons. And we had the animation set on this setting. If I hit start, we could see the sun moving to the south as we approach December 21st, lowest point in the sky, lowest path for the sun. Went a little bit past, but there's December 21st. And we could see a low path to the sun, short duration, meaning the length of this yellow line is not very long. The yellow line represents the path of the sun, how the distance that it travels through the sky. And as we progress through the seasons and we go into January and February and March, March represents the spring or vernal equinox. Okay, that's roughly there. 23rd, 21st. This represents the equinox. Equinox means equal amounts of day and night. No matter where you live in the world, you're going to have a 12-hour day and a 12-hour night. And then we continued with the animation, and as we go along, we approach June 21st. Right now we're in May, we're right around here. We get to June 21st. There's June 22nd. This would be the highest point of the sun for where we live. And a common misunderstanding and things people don't really think about is that where we live, we'll never see the sun directly over our head. It gets very high in the sky in June, but it never gets directly overhead, which means we always have a shadow where we live. As we continue the animation, now we see the sun going back toward the southern horizon. We get to fall equinox, September 21st, fall equinox, or autumnal equinox, and we can see the length of the shadow getting much, much longer. The lower the sun is in the sky, the longer the shadows. Now, as we continue, we can see the sun get lower and lower and lower. Now, if we go back to the worksheet for a minute, let's just get you through that, and then I want to show you a couple other things. Let's just take a quick look at the questions. How does the altitude of solar noon sun change from December 21st to June 21st? We went through that. You should be able to do that, I think. The yellow line is the sun's daily path. Based on the length of the line of what happens, we went over that. Number 3, I think you can do. Number 4, what time does the sun rise on June 21st? Include AM and PM. So now what I'm going to do is go back to here. I'm going to grab this bar and slide it over to June, and we're going to go to June 21st. And it's asking, what time does the sun rise? So now what I'm going to do is, well, find where sunrise is. So I'm going to go backwards. Here's 12 o'clock p.m. That's noon. So I'm going to go backwards. There's, whoops, going the wrong way. Let's go back here. There we go. All right, so there's the afternoon. I went the wrong direction. Now we've got June 21st, 11 p.m. Something looks really strange about that. Around June 21st. Let's go to continuous. Let's do that. Okay, there we go. So June 21st, the day of the year is here. Sun is rising in the east. Time of day, 4:32 a.m. And then as we go along, we can see the sun rising. There would be solar noon. So let's go back to that for a minute. Sorry, that gave me a little bit of trouble there. Let's go back to sunrise, and I'm going to stop it. It got away from me. Let it go around again. Okay. I'm going to grab the time here. This is another way you could do it. It's just going a little fast for me. Okay. There is the sun rising, and we lost track of our days here. Things got a little out of control on me. There we go. All right, so that looks to me like 4:16 a.m. roughly is sunrise. That might seem very early, but on June 21st, the sun does rise very early. So that would be the sunrise for June 21st. And something else that is worth pointing out here is that a lot of the time people say, well, the sun rises in the east and sets in the west. And that is true, but it is only somewhat true. In the summer and in June, the sun rises not on due east, but north of east. Anyway, now I'll continue the animation. Now, right at this point, we've crossed into the southern half of the sky. So in June, the sun rises in the north of east, in the northern half of the sky. It crosses over into the southern half of the sky. There's solar noon. Now it crosses into the northern half of the sky again. And there we have sunset around 8:05 p.m. So that's how we would get sunrise and sunset. So sunrise June 21st, sunset June 21st. And you can go back in the video, look at those times. Now over here, it's going to ask you to do the same thing for the equinoxes and for December 21st. And I'll leave you to do that on your own. Okay, but I do want to just point out a couple things to you. So in June, the sun rises north of east and sets north of west. Now, if we go back to the equinoxes, it doesn't really matter which one we go to. The path of the sun is the same for September 21st or March 21st. It doesn't make a difference. We'll do September. Now, on the equinox, we can see, well, if we go to sunrise, there it is. The sun rises right on east, and then it progresses through the sky, southern half of the sky, and it sets on due west. So when the sun rises in the east and sets on the west, exactly on due east and due west, that only happens 2 times a year, on fall equinox, autumnal equinox, and vernal or spring equinox. And then if we go to December, now the sun rises south of east. And there it is there. So now the sun isn't rising on due east. It is rising generally in the east, but south of east. It has that low path through the sky, and it sets south of west. Now, just a couple other things that I wanted to point out to you were shadows. Again, when the sun is low in the sky, we have long shadows. We can see that long shadow there. But we could also learn something from the shadows. We can learn the direction of the sun. If we go back to June, and let's start the day over again. It doesn't matter that I'm not on June 21st for this. Okay, but now we have the sun rising. And again, in June, the sun rises north of east. Here's east. It's rising to the north of east. We can see our shadow is facing south. The shadow is always going to point the opposite direction the sun is facing. So if the sun is in the northern half of the sky, our shadow is going to be facing the southern half of the sky. And as we go through the day in June, once we cross the southern half of the sky, well, now the sun is higher, so we have a smaller shadow. But now our shadow is pointed to the north. Your shadow is always going to be the opposite direction the sun is facing. And the length of the shadow is going to give us an idea of time of day and how high the sun is in the sky. The higher the sun, the shorter the shadow. Now we're back in the northern half of the sky, long shadow to the south because the sun is setting. So the sun is always going to be on the opposite side of the sky as your shadow. So if we have a shadow to the southeast, that means the sun is going to be in the north west. Okay, so the sun is always going to be in the opposite side of the sky. Now, one last thing that I wanted to point out was this is really what the sky and the sun does where we live. If we go to, say, the equator, well, now we have a very different path to the sun. And as we go through a year at the equator, well, now things are vertical. And it's not so much that things are vertical. We have to think about our position in space. Now the sun and the rays from the sun are hitting the equator dead on. And we can see the sun rises in the east still, but it goes up and over. It doesn't have that angle to it. Now we still have the sun moving back and forth between 23.5 degrees north and 23.5 degrees south. And that's due to Earth's tilt. The reason we have seasons in the first place is due to Earth's tilt. I'm going to go back to step by day. And as we watch the animation go, we'll see the path of the sun going back and forth between 23.5 north and 23.5 south. I'll change that back to noontime. I have to reset that. Let's bring the sun back around. There it is. Okay, so now the sun gets to its minimum point, 23.5 degrees south. This would be Tropic of Cancer, actually, on a globe. And then it goes back up. There we go, equinox, summer solstice. So even if you lived at the equator, you're still going to have a shadow most of the year. But as we see, as we approach the equinoxes, your shadow gets smaller and smaller and smaller. And right on December 21st, you would actually cast no shadow. So if you wanted to go to a place and not have any shadow, you'd have to be near the equator, somewhere between 23.5 degrees north and 23.5 degrees south on the right day of the year. On the equator, that would be on the equinoxes. Now, if we go to a different place, let's say 23.5 degrees north. I was able to do this once. I went to an island in the Bahamian Islands. Let me go here. 23.5 degrees north, right on summer solstice, just by coincidence one year. So I did south. Let's change that to north. Okay. And now if we go to June 21st, we have that tilt again because we're not on the equator. There's winter, right? And now the sun's moving north. There's our shadow. Our shadow's getting smaller and smaller and smaller. There's the equinox. But then once we get to June 21st, now your shadow goes away. And on June 21st, no shadow. And now your shadow starts to get bigger again. If we were to go to the North Pole, we'll see some interesting things. So for one thing, if you're at the North Pole, no matter where you look, is south. You can't go north if you're at the North Pole. So if you're at the center of the North Pole, or if you're right on the North Pole, the only direction you could go is south, right? So if we start the animation here now, we'll see the path of the sun. Well, it disappears because the sun is not shining at all in the winter. The Earth's axis is facing away from the sun, so there's no path to the sun in the winter months at all. So here's winter solstice, December 21st right there, but there's nothing to see because the North Pole is in darkness. Once we start getting into the springtime, we'll start to see the sun emerge. And there it is there. Now, if we switch to continuous, and we'll see the path of the sun as it travels through the sky, we'll see the sun moves in circles around the sky. And this is the 24 hours of daytime that you would see if you were at the North Pole in the warmer months, the summer months. As we approach June, we'll see that the sun gets higher and higher in the sky. And then once we get past June 21st, it's going to start getting lower again. So the path of the sun is different for different parts of the world. We looked in depth at Goshen. There it is, it dropped off again. Now it's 24 hours of darkness. But it's important to remember the path of the sun is going to look different for different parts of the world. At the South Pole, it would be the same pattern, but opposite seasons, of course. And this has to do with our view of the sun from where we live. So finish up that worksheet on your own, and there'll be some other things for you to do in Google Classroom as well.